All right, guys. I need to back this up just a little bit. There we go.
All right, we gotta be focused.
All right. So if we focus, we can get through this pretty easily. Okay. So if you take a look at this, yesterday we talked about sometimes there's hidden information. Okay. So you've got to remember you need 3 things to tell me that a triangle is congruent. So if you take a look at the first picture, they tell you that angle FGJ, so FGJ is a right angle, and angle HJG is also a right angle. So that's given to you. They tell you that they're congruent because they're both right angles. They also show you that F to G and H to J are congruent with these symbols. So they gave you 2 pieces of information. Okay? They did not give you that third piece. So you have to be able to look at your picture and say, okay, well, they share this side in common. Okay? So we can say and state that GJ and JG are congruent by the reflexive property. Okay? So it's all going back to this that we talked about yesterday, about how you could have vertical angles that they don't mark, but you know that they're congruent because they're vertical, that they share a side, so that's reflexive sides, that they share an angle, that's reflexive angles. So if you take a look at the next one, what 2 pieces do they give you? Do they show you?
Side.
To DB, okay, that's this side here that's marked with a 1 and this side here that's marked with a 1. They also give you another side. So EB is congruent to CB. What piece do you know that is also congruent that they didn't mark? Vertical angles. You've got vertical angles. This angle right here and this angle right here are vertical. So you can say that angle EBA is congruent to angle CBD because they're vertical angles. So now that you have 3 pieces of information, what postulate is this that we learned yesterday? Side, angle, side.
Oh, that's a postulate.
Yes. No, you're fine.
Oh.
Okay. So now that you can prove that those are vertical angles, you can say that these triangles are congruent because they're side angle side. Okay. On the next triangle. Yes, sorry. Okay. On the next triangle, what do they give us? What can you see? Okay, so we've got sides. You've got side M to N is congruent to side P to M. What other piece do they show you? I heard Daniel, that's it.
Yeah, Daniel said it. I'm like, is it wrong? Is that what she didn't say nothing?
I was just waiting to hear from more than one person in the class.
I figured he already said it.
You got your right angles, okay? You got your right angles. So we can say that angle NQP is congruent to angle NQM. What third piece is there that they don't tell us? That side that they share in common. they share this side in common right here. So they can say that NQ is congruent to QN because they are reflexive. So then what postulate would you use to say that these triangles are congruent now that you have three pieces? SSA doesn't work. What does that spell backwards? SAS is not going to work either because the angle is not in the middle.
Is it not?
What?
HL.
HL. These are right triangles.
Oh.
Your hypotenuses are congruent, and this leg here is congruent. So this is hypotenuse leg.
Whoa, I didn't remember that. I remember that's what HL meant.
That's the one that most people forget.
I didn't remember going over that.
That's going to be one that most people will forget. Okay? Take a look at this one. They tell us that angle RSU is congruent to angle TUS. Uh-oh. They only gave us one piece. That's it.
It's a parallel.
Ooh, but it's a parallelogram.
Oh, I didn't. That was actually good.
You are absolutely correct. That's what these means. This line and this line are parallel to each other.
That means the other ones are too.
Okay, so Brandon just said that means that this angle then is congruent to this angle. And he's absolutely correct.
Another piece.
They give you another piece that's not there. Yes.
Look, y'all, I didn't even know
No,
that.
you can't do that with the lines. Okay, so you can say that angle TSU is congruent to angle RUS. Russ. What else can you see from the picture that they did not give you? What'd you say? S what? SU. SU. They share this line SU in common. So we can say that side S to U is congruent to side U to S. Okay, so sometimes they're only going to give you one piece of information, but you can deduce because they're parallel lines that you've got an extra two angles that are congruent, and they share that line in common. That is actually a thing, Brandon. Look at you. Smarter than anybody else. Bam! There it was. The light. Yeah, you're right. Okay, so on this one, side VW is congruent to side ZY. And they also tell us that angle VWX is congruent to angle ZYX. What hidden piece of information is in this picture? Vertical angles. So this angle here is congruent to this angle here, which means that angle VXW is congruent to angle ZXY. Okay. Take a look at the last one.
Wait.
You could do that as an HL. Okay, we can definitely do this one as an HL. Or I could do this one as side angle side. What is this figure at the bottom? It's a rectangle. So if this is a rectangle, that means that this side is congruent to this side, this side is congruent to this side, and then they share this side in common. So you could technically use side, side, side here as well. Okay, there's a lot of information you know when this is a rectangle.
Side, side, side.
Okay,
side.
so you could use side angle side, you could use side, 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 you could use hypotenuse leg here. So the only thing that they truly give us is angle D prime, A prime, B prime is congruent to angle B prime, C prime, D prime. Dab. Okay, and then you can give me any other piece of information you want. You can give me that DB or D prime B prime is congruent to B prime D prime. That's that side they share in the middle. You can tell me that A prime B prime is congruent to C prime D prime. Or you can give me that A prime D prime is congruent to C prime B prime. Okay, any of those would work. And again, you can use a multitude of postulates here because of the fact that there is a rectangle, so you know multiple different things with a rectangle. Okay. Questions? All right.
Oh my God.
So we're done with congruent figures. The last thing we need to do in this unit is similar figures. Okay, so this all technically goes back to Unit 1, transformations. A congruent figure was a rotation, reflection, or translation. Here, similar figures are what kind of transformation? What's the only one I didn't list? I talked about it's a translation. It could be the slide. It could be the rotation, the turn, or it could be the reflection, the flip, or congruent. Which one was not congruent? It began with a D. Dilation. Similar figures are figures that have been dilated. So they're the same shape, they're just not the same size. So they're either blown up by like 3 or they're shrunk in half. Okay, so we've got 3 postulates that will tell you that these are similar. So if you can prove that 2 angles of one triangle are congruent to 2 angles of another triangle, then your triangles are similar. That's the first one. It's AA similarity. Okay. So if you open this up, are the 2 triangles similar? And if they are, state how and write your similarity statement. So I've got 2 triangles here. My first one is this triangle up here. Okay, this little tiny triangle up here. The second triangle is this big triangle. Okay, so all that they tell us is that this angle and this angle are congruent. In order to prove these triangles similar with this similarity postulate, I have to prove that another angle is congruent. What is it, Brandon?
Because it's like they share it.
They share this top angle in common. So that's your second angle that is the same. Okay, so we know then that angle XWV is similar. So instead of using the congruent symbol, you're only keeping the wavy part. That's your similar figure. So XWV is similar to angle XZV. That's the one that they give us. Okay, that's the one that they give us. XWV is similar to XZY. The second one that they do not give us is angle WXV is similar to angle ZXY. Notice that the angle that's actually similar is the one in the middle when you name these. That means they're similar. Yeah. If you do that symbol with the equal sign, that means they're congruent. If you just do that symbol, that means that they're similar. Bless you. So then I can finally say, I can write a similarity statement that triangle XWV is similar to triangle XZY. That's your final similarity statement. And how do I know that? Because those two angles are similar. Or I'm sorry, it shouldn't be those two angles are similar. Those two angles are congruent. Add your equal sign underneath there. I'm going all types of similar. Those angles are congruent, therefore that the triangles are similar.
What's that? It's Friday.
Yeah. Oh man, I'll put
just put your equal sign underneath it.
I know, but I'll put an arrow pointing to it and say Did you say me too?
All right. Let's go over here. Are these two triangles similar? And if so, state how and write a similarity statement. So I need to find two angles in these two triangles that are congruent. So I've got this triangle here. And this triangle here. Yes.
So if a line goes into a straight, if one line cuts through two straight lines, or is it going to have the same angle where it cuts? Like the same angles?
So, hold on. Show me what you're talking about.
So like this line, it goes through these two. So would it be the same here and it is here?
Yes, because these are parallel. Yes. Okay. So, Brandon just said, I've got two parallel lines here. One here and one here. So he says that this angle is congruent to this angle. Okay? Because what you technically have is two parallel lines with a transversal that cuts through. So this is congruent to this because they're alternate interior angles. Okay, so I can say, yes, ma'am.
Is the word next, like where the X is made, is that vertical?
Uh-huh. Okay, that'll be your second one. Or you could have used the other ones too. Okay, so I can say that angle HGF is congruent to angle HKJ. And that's because these are alternate interior angles. Okay. Well, if that's the case, I can also say the same thing about J and F. Or I can do vertical angles here and here. Did I have to prove all three of them? No. But can I? Sure. So as long as you've got two pieces of information, you're good. So I can say that angle JHK is congruent to angle, that's going to be FHG, and these are vertical. Or I could have said that angle KJH is congruent to angle GFH. And these are also alternate interior. So now that I know that these are congruent, I can say that triangle GFH is similar to triangle KJH. Okay, so let me tell you this. You normally don't have to list all of these because it's going to be multiple choice. So you won't have to list all of this. You just need to know it. And then you can just give me the similarity statement. Okay, they don't usually do formal proofs, which is technically what we just did. Okay, because it's not an open-ended test, it's multiple choice. So normally they'll just give you this picture and say, they'll give you choices. Triangle such and such is similar to such and such. They'll give you 3 of those, and then they'll usually give you one that says the triangles are not similar. And you've got to pick which one works. So you won't have to list all of the pieces, but you'll just need to be able to visually see them. Okay. The second one, to prove that triangles are similar. If I only know one angle, that's fine. But if I know one angle, I need to know 2 sides. So it says if 2 triangles, if a pair of corresponding angles are congruent and the sides are proportional, then the triangles are similar. Okay, if the 2 triangles are congruent with 2 congruent angles and 2 sides that are proportional, then they are similar. So notice it's SAS again, but this is SAS similarity. Okay, so let's open this up. Are the 2 triangles similar? If so, state how and write a similarity statement. Okay. So in order for me to do this, I have to have one angle that is the same. Do I have that?
Yes.
Yes. I know that angle MNL is congruent to angle PRQ. Okay, so I've got the first piece. I now need to show that the other 2 sides are proportional. So the way that you do this is you set up a proportion. So you make a fraction out of these 2. So this becomes 4/6. I got that from here and here. So if I do 4/6 for this triangle, my second fraction has to be 6/9. Okay. Now you just need to make sure that this is a true statement. So how do I solve a proportion? Cross multiply. So what do I get when I take 6 times 6? 6 times 6 is 36. 9 times 4 then is 36. Is this true? Yes. So that means that triangle MNL is similar to triangle PRQ. You have to get proportional sides. Four 6 is 2/3 and 6 9 is 2/3. Yes. Elijah just said, could I just have simplified both fractions and made sure they were equal? Absolutely. 4/6 reduces down to 2/3. 6 9 also reduces down to 2/3. 2/3 and 2/3 are equal. You're good. Okay. All right. Let's move over to here. This is where it gets confusing. Okay. So looking at this, again, SAS tells me I need one angle congruent. Do these 2 triangles, yes, have a congruent angle? They share angle L. So I can say that angle KLM is congruent to angle ELJ. There's my angle. Okay. So let me highlight these because I think this is easier to see when I do this. Okay, so here's your first triangle. Here's your second triangle. The other one was pretty easy because they were already separated. Okay, so now I proved that they have two congruent angles. I need to prove that my sides are proportional. So this little triangle has sides 6/10. What's my other triangle have? Ooh.
5/30.
No, it's 15
9
over
over
9.
15.
9/15.
Something like that.
My big triangle is this whole side. Well, this little piece is 3, this little piece is 6, so this whole side is 9. This part of the triangle is this whole side. So 10 and 15, or 10 and 5 give me 15. So this is technically 9/15. Okay, so do we want to take Elijah's shortcut and see if we can just reduce it? What does 6/10 reduce down to? 3/5. What's 9/15 reduced down to? 3/5. They're equal, so we can say that triangle KLM is similar to triangle ELJ. I like SAS better than. The only one that I truly hate is the next one we're about to do, because you have to do all 3 proportions and make sure they're correct. Yes. What makes no sense? It's not an equilateral triangle.
I know, but
Wait,
if
it
you had
looks like
9 on one side and 15 on the other side, it'd be like this.
it should
Okay.
be obviously different.
I'm going to tell you
It would
this
be
right
like
now.
this.
They don't draw figures to
They
scale.
don't need to be this
But
scale.
They're
It's supposed to be like show a
They at
little
least
bit
need to
of
have the
difference.
angles right. How you gonna mark an angle 185 and then
And it's like
it's
But
actually
listen.
like
4.
This is how they confuse you, because some people will look at that and be like, oh, well, that kind of looks like an equilateral triangle, and not pay attention to the numbers. This is how they get you.
What if they like go in detail and like measure it out and everything? It turns out to be one.
I've never actually measured this out to see if the proportions are actually correct.
I've thought about that.
Okay, so your last one is side similarity. If all 3 pairs of your corresponding sides are proportional, then the 2 triangles are similar. This one is a pain in the butt. You have got to do the proportional sides 3 times to use this one. Okay, so open this up. Are the 2 triangles similar? If so, state how and write a similarity statement. So I've got to do this 3 different times. I need to do is 7/15 equal to what over what? 30/45.
Wait, no, wouldn't it be 21/45?
Whoa, good point. So take a look at this. Don't write 30. Just don't. Okay, so take a look at this. This is small. That should be paired up with small. My middle number on this triangle is 12. The middle number on this triangle is 30. The big number on this triangle is 15. The big number on this one is 45. So if I do 7/15, that's small over big, which means over here I need to do 21/45. Good catch, Brandon. You are smart. I just wish you'd do homework.
Do my homework.
Not always.
Would that be
Sometimes.
3 over?
So
I feel like it.
we can reduce the right-hand side to see if this works. What does 21/45 reduce down to?
No.
What goes into 21 that also goes into 45? 3. What's 21 divided by 3? 7. What's 45 divided by 3? 15.
Whoa.
So yes, those ones work.
So you don't have, because that was already reduced, right?
You can cross multiply. So if you cross multiply, that's
Way much. Like,
315 equals 315.
Way too much.
Okay, so you can do it either way. You can cross multiply or you can reduce. Both ways work. Okay, so I checked small over big. I need to pick another one. So I can do 7 over 12. If I do 7 over 12, it's got to be 21 over 30.
Seven over 2. On the right
7
side.
over 10.
Okay, so this one, when I reduce, becomes 7 over 10.
That don't work.
That doesn't work.
I mean, they're kind of close, but like.
So that's an and. So at this point, if you're trying to use side similarity, and you get one that doesn't work, these are not similar.
How do you write that?
You just write not similar.
I tried a big no.
Or sometimes they'll put triangle. You'll see triangle RQP is not similar to triangle, and they would use, that would be ONM. So they'll just use the not similar and put a slash through it, just like you can do with the equal sign and put the slash through it to say that they're not equal. Okay.
Dude, I ain't seen something like that since like 5th grade.
Onion.
Yeah, so
That's it.
Are these two triangles similar? Okay, so I would do just what I did on the last one. What's my small number on my little triangle? Whoa, oh.
34.
So Jeremiah just said, well, they don't give you this side and this side on your small triangle. They tell you what this is and what this little piece is. I need to find this piece. So that one's 32. Good. This would be 88 minus 56, which is 32. And this one's 143. Yes, it's going to be 52. Okay. So be careful with that. So my small side is going to be 32 on this triangle. What's my small side on the big one? 88.
what? I'm confused. Oh, wait, never mind. I got it.
Got it?
Yeah.
No.
What did you say?
Okay. So here's, hold on. Let me highlight. Maybe that'll help. Here we go. So here's your small triangle, which is 32, 44, and 52. Okay. Here's my big triangle. Whoop. I want my highlighter. Here's my big triangle, which is 88, 143, and 121. Okay. So my small numbers out of these three is 32. My small number out of these three is 88. It is. But your big triangle is both of these pieces together. Does that make sense? Okay. Okay. So 32 would pair with 88. What would 44 pair with?
Whatever numbers on the
121. And 143 would pair with 52.
Wait, does that mean
What happened in 91?
Does that mean 88 and 56 are together? No.
56 and 91.
56 and 91 are nothing with these triangles.
What?
56 and 91 are just this section from here to here. And that's just there so you can tell me how long this one is. Do I have some white out? Yes. So 56 and 91 really has nothing to do with when you're trying to prove these similar. Those are only. Oh. What do you need me to
Look at it, it's not really
triangle around it? I'm gonna have to just like. You're welcome. She said, you know I can't do that. So we're gonna try. Let's do 32 over 44. Which means that goes with. What's that go with?
Oh, wait, 32 over 30.
88 over 121.
Wait, 32 over
Why are we doing 52 over 40?
would be 88 over 120.
Oh, I get
We have to do all three, Brandon.
Yeah, but why don't we do like smaller big first?
Doesn't matter which one you do first. You've got to do all of them.
I know, but that's what we're doing.
Shut up!
You telling me small question, I question it.
Right. Look what you did.
I tell him he's smart, and he's like, "Oh, but why? What? Huh?"
Right, now he got a question. No. You're not going to be right all the time.
It doesn't matter which one you do first. I could have put 44 on the top and 32 on the bottom, which just means my second one would be 121 over 88. Okay, is anybody confused where these fractions came from? You need to stop and, did I just hear yes?
Yes.
Who did I? You're fine. No, I want you to ask these questions because I guarantee you there's several more people in this room that are thinking the same thing and they're just too afraid to ask. I need those bold kids that are like, look, help.
Okay, fine. Look.
That's why I love her. She's like, help.
We're like,
All right.
See what we not about to leave.
So where are you confused?
It's kind of just like from everything.
From everything, okay?
Like just a broad.
Okay, so do you understand why 32 goes with 88 and 44 goes with 121?
I mean, sort of just because they're kind of.
Okay, so let me try this. So let me try this.
I'll ask questions real quick. I already know.
But that's what I need.
Nobody's doing
Because nobody's going to take your education from you.
Right.
Kinsey, do you at least understand where we got 32 and 52 from? So you're good there. Okay. Okay. 88 over 121. And this is 143. Okay. So 4, 6, and a triangle here, it would have to be the same scale. So if this is 2, 4, 6, and I make this side 4, that means this side would have to be 8, and this side would have to be 12. Because you'd have to be able to multiply each one of these by 2. Because it blew up by 2 then. It's a dilation. So that means that this and this are the two small sides, one from this triangle, one from this triangle. So that would be 2 over 4. This one and this one, that's the medium side of this triangle. The medium side of this triangle is 4 over 8. Well, this is 1/2, this is 1/2. So the small has to be paired with the similar side. So the small and small go together, your medium and medium go together, your large and large go together. So if I look at this triangle here, my smallest side is this one. My medium side or middle side is that one. And my big side is this one. Okay. So then if I go over to this one, my small number is here. My medium number or middle number is here. And my big number is here. So that means that this one and this one pair up. This one and this one pair up. And this one and this one pair up. because they're similar in terms of the triangles. Small has to pair with small, medium has to pair with medium, big has to pair with big.
Oh, I was looking at it wrong.
You good?
No, yeah, we're good now.
Okay. Anybody else? Yes.
I just came up with another way to do this. If you divide the big number from the big triangle and from the big number of it, okay. If you take and make a fraction out of
So
the
are
big
you
number
going
on
like
top,
143 divided by 52?
yeah,
What does
they
that
all
give me?
equal
121 if they're all the same.
2.75.
Yes, I'm gonna let you run with that because I don't wanna like throw everybody else off. 100% that works. Highly impressed with your skills, my friend. Okay, so if you want to stick with the reducing, your calculator can do that for you. So if you go into your calculator and put in, well, most of you don't have one. All right, let me step back here. Hold on. Silly people in math class that don't grab calculators. So if you would go 32 divided by 44, if you don't remember how to reduce this, and you hit math and pick fraction first, that's going to be 8/11. Are you planning on coming third period today? They're testing.
I thought you said today.
First period.
Oh.
Monday, Tuesday, Wednesday, third or fourth would work.
Oh.
So
So
if we
in that email it said 3, 4, so I was like,
Third and fourth, and then I put Monday, Tuesday,
but
Wednesday.
you ain't put no spaces, so
Oh,
it didn't make sense.
yeah. Oh, sorry.
No,
yeah.
okay.
So if we could switch it to Monday, Tuesday, Wednesday,
Okay.
that'll work.
Got
Okay.
I got it real quick.
Okay. So this is 8/11. 8/11. And then you would do the same thing to the other side. You would plug in 88 divided by 121. And again, choose fraction. And that gives me 8/11. Whoa.
Is that Miss Smith?
I understand that.
Okay.
You are.
So the two fractions are the same.
You are.
Somehow I got that.
You know what? You're always so many times.
Rabbit.
Jeremiah's always one.
I don't know what you did either, but let me get through this. All right. So again, you've got to do this. Please stop because we have 4 more examples we have to get through. And yes, you have homework tonight. Okay.
One.
So you've got to do all 3 sides. So I did small and middle. So let's do middle and big. So 44/52 and 121/143. Let's just cross multiply. Those of you that have calculators, what's 52 times 121?
Only 2 people have.
Whatever, got you. Wait,
52 times 121.
6,292.
Okay. And then do 44 times 143.
6,190.
Okay, so that one works. Okay, so we did small, middle, middle, big. We've got to do big, small. So 52 and 32 and 143 and 88. So somebody do 32 times 143 and somebody else do 88 times 52.
32 times
4,000.
is 4,000. Yeah.
4,000 what?
570.
76?
She was drunk.
Is that the same for 52 and 88?
Yeah.
Okay. So you proved that all 3 sides are similar. So now I can say that triangle KLM is similar to triangle DLE. That is proving them similar. The last 4 we need to do is how do I find a missing piece if I know that they're similar? 117. Okay, that does not give you the right to talk. We've got to get through this. are, if you need to draw a picture or not. Visually, I will do it visually for those of you that need the picture, okay? Just understand I'm not an artist, okay? Please understand that. So this says I have a tent. Here's my tent. Nyeh. That's my tent. I told you I'm not an artist. This tent is 6 foot tall. And it casts a shadow along the ground that's 9 foot. So the height and then the length of the shadow. Okay? Right next to that tent is a cardboard box. I don't know. There's a cardboard box. Okay? We don't know how tall this box is. But I know that it casts a shadow that's 6 feet long. So now I can set up a proportion to figure out how tall my box is.
It's gonna be 9 feet.
So 6 over 9, the height of the tent over the length of the shadow equals the height of the box over the length of the shadow. Okay? If you put height on the top, it needs to be height on the top on the other side. If it's shadow on the bottom, it has to be shadow on the bottom on the other side. So 6 over 9 should be something over 6. So when I cross multiply, I get 9 times some number I don't know. You can make it X if you want. Equals 6 times 6, which is 36. Divide by 9. That means my cardboard box is 4 feet tall. That's a pretty big cardboard box.
Right. That's not the
It's
that's
a-
me. That's
That's
the
like a
tallest
TV box.
as me.
It's almost as tall as can be.
No, I'm like
Well, that's a little bit
Like,
taller.
AK.
Hey, listen, you threw that yourself. Okay? All right. Most of you probably don't even know what the heck this is. A telephone booth that they no longer exist.
I do.
Okay? So you've got a telephone booth that's 8 foot tall. Oh, you're getting a line. You're getting a line out of me. 8 foot tall.
Draw a whole doctor to a telephone.
Shh, no.
Why?
And it casts a shadow that's 4 feet long. I need to find the height of a lawn gnome. All right, I'll draw you a lawn gnome. Here's a lawn gnome.
Oh, you'll draw an intricate little person, but you won't draw a box.
There's my lawn gnome.
That's an intricate person, but you won't draw a box.
Is that the Grinch?
No, Jeremiah, it's you.
Wait, is that Santa?
Is that Santa?
Why are you guys stop talking about little people like that?
Okay,
Oh, a lawn
a lawn gnome. Yeah, like the little scary looking dude
gnome.
that.
Romeo.
Haven't you ever seen
No,
Romeo?
Romeo,
Romeo
I've
and
seen
Juliet?
that. I thought you said long nose.
No, lawn gnome.
Why would that be?
All right. So
What would that be?
Listen. Here's another way to look at this. My shadow went from 2 feet to 4 feet, so that's multiplying by what?
2.
2. So what would I multiply by 2 to get me 8? 4. So your lawn gnome is 4 feet.
Whoa.
Okay? So you could have set it up as a proportion. 8 over 4 is question mark over 2. You get 4 question mark is 16, and you would divide by 4. Well, guess what? You still get 4 feet.
That's amazing, bro.
Okay? So both ways work. Again, it's proportional. So if I multiply by 2 to get to one side, I've got to do the same thing to the other piece.
What's everything 4 feet tall?
I don't know. I noticed that on this one.
Like, how am I supposed to get in that telephone?
All right.
How
So
are you supposed to get in that middle?
a map. A map. Every 3 centimeters on a map is 18 kilometers in real life. Okay. So every 3 centimeters is 18 kilometers. So 3 centimeters and 18 kilometers. The only other piece of information they give me is it's 54 kilometers apart in real life. So where does that number go in the second fraction?
Bottom.
Bottom. Good. So 54 kilometers. We need to know what this is.
what's 54?
What do I take? What's 54 divided by 18? 3. So I would do 18 times 3.
No, 3.
The answer is 9.
The answer is 9. So I would multiply 18 by 3 to get 54. What I do to the bottom, I also have to do to the top, which makes this piece 9 centimeters. Yes.
Couldn't you just multiply 54 by 3 and divide it by 8?
Yes. That's cross multiplying. Okay. So Shelby just said, can't I just do this? And that's going to be 12,162. And then you divide by 18. Absolutely. Okay. It does the same thing. Okay. So finally, the last one, a model. Whoa, sorry, Lauren. She's like, whoa, Miss Smith, come on.
Miss Tiffany dropping papers.
I'm dropping my life. I dropped my head on the floor if it wasn't attached.
So you do.
I feel like my parents would.
Try number 4 on your own.
I really don't
Number 4 was easy.
Number 4 was easier.
Yeah.
All of them was easy.
All of them were easy. I didn't do it first.
If you didn't glue in these 2 papers, the first one we did glues in on 117. That second one glues in on 118. 3, 4, and 5.
I just looked at it and I was like, yo, that's
2, 3, and 4.
Are you?
I'm gonna put it up here in a minute. See if you can figure it out. 2, 3.
Jeremiah, when's your birthday?
I'm long.
I have February, this is my first.
25th, my bad.
Yeah, February 25th, my bad. I was thinking 21st was something else.
4.
Thank you. Real friend. And go first.
Okay. All right. Real fast. I just need you to be quiet real fast so I can run through this. Okay. So my scale is 3 centimeters over 4 meters. That means on the second side, they give me centimeters. So it has to go in the top, which means the question mark's in the bottom. Well, to go from 3 to 12, I would multiply by 4. So here I can multiply by 4, which means this is 16 meters.
So essentially, you just add 4.
Okay. What do you mean you add 4?
You just add 4 to 12.
You can't use that.
I know, but like still, it's the same thing. Like it works.
It works for this one. It's not going to work for everyone.
This glue's on a 118.
Okay. 118.